All right, remember your plan of attack for acids and bases so far is if you identify that what you have is a strong acid or a strong base, you're going to go straight to pH or POH. If you identify that what you have is a weak acid, put the acid in water with some ice and a twist of Ka. Let's do a next example. This problem says, calculate the pH of a 0.20 molar solution of benzoic acid, given that its Ka is 6.3 times 10 to the minus 5. So we go to identify what we have. Well, clearly we have an acid. It said we have an acid, so it's an acid. Now, is it a big 6 acid? H with chloroclonoso? No, it's not a big 6 acid. It is a weak acid. That's why they gave us a Ka value. So the plan of attack, take that acid in water and ice it with a Ka. Now, I really don't want to write down this whole acid. I don't want to write down, it's such a long formula. So instead of writing the whole formula, I'm just going to write the generic formula for a weak acid, H with all the rest, HA. We're going to take that HA, put it in water. It's a weak equilibrium dissociation. We get some hydronium ions when we donate a proton and the conjugate base A-. There's our acid and water. Now we go to ice it. The original concentration of the acid is a 0.020 molar solution. 0.020. We don't have any initial H3O plus hydronium or A- conjugate base in our solution to start. This begins to dissociate. We take away X, we add X, we add X. And at equilibrium, the A- is X, the H3O plus is X, and we're going to be able to rule of 100 this. If 100 times the Ka is less than our start, which it is, we can drop the X term and simply call this 0.020. We're going to take that Ka value. The Ka value is equal to the products H3O plus multiplied by A-, all divided by HA. We're going to take that expression and plug in all the values that we have. We know the Ka is 6.3 times 10 to the minus 5. We know H plus, H3O plus, and A- are both X's, so that leaves us with an X squared term on top. And on the bottom, we have 0.020. All right, now let's go ahead and solve for X. Multiply both sides by 0.02, take the square root, and we get an X value equal to 1.1 times 10 to the minus 3 molar. Now, what is X? We go back up, we look at our ice table. X is our H3O plus hydronium value. Since we know the H plus, we can go directly to pH. pH equals negative log of the H3O plus value. The pH here is going to be negative log of 1.1 times 10 to the negative 3. I know my answer is going to be very, very close to 3. It's going to be 2.95. 2 sig figs in my concentration unit. I keep 2 decimal places. And then you always want to do a double check. We got a pH of 2.95. We said we had a weak acid. This is an acidic pH. Makes sense. I hope that helps. Take care.